Hi students, good morning to you all. I am Rajeshwari RTPS from Gundlakunta. In the previous video, we covered the basics of reflection. In this video, we will cover the types of curved surfaces, how the curved surfaces are used to make spherical mirrors, and their uses. First, we discuss about the curved surfaces. There are mainly two types of curved surfaces. Any curved surface is part of the sphere. See this figure here. We can see that the sphere is cut at 2 points. Then we get the curved surface. If you see one part of the sphere, that is one curved surface, we can see two curved surfaces. One is the outer part and another one is the inner part. The inner surface is known as concave surface because if we observe the surface, it is like a cave, so it is called as concave surface. In the same way, the other curved surface is known as convex surface. In this way, the curved surfaces are two types. One is convex surface and another one is concave surface. If we draw the surfaces as shown in the figure, see the curved surface. We can see two surfaces. One is concave and another one is convex. We can make the curved mirrors by using these curved surfaces. The mirrors we can made by these curved surfaces are two types of mirrors. They are concave mirror and then one is convex mirror. These curved mirrors are also known as spherical mirrors. Here we can know how the convex and concave mirrors are made. Let me explain you about that. The household mirrors are normal plane mirrors. Can you know how the normal plane mirrors are made? It is a glass piece. Any glass, normal glass piece taken and one of its side is silvered. That means coated with any metal oxide. The other side is non-coated side behaves like a mirror. In this way, we can make a mirror. We can make this mirror by using a glass piece. One side is coated and then another one becomes the reflecting surface. On that we can see our image. In the same way, we can make the spherical mirrors. If we want to the concave mirror by using the spherical surface, then we have to silver the convex surface of the spherical surface. That means we have to silver the convex surface of a spherical surface to make a concave spherical mirror. In the same way, we have to silver the concave surface to make the convex mirror. The non-silvered surface are the reflecting surfaces. The non-silvered surfaces are also known as reflecting surfaces. Observe the figure. Here we can see that in the convex mirror, concave surface is filled with small crossed lines. These crossed lines shows the silvering. In the concave mirror, the convex surface is filled with crossed lines. These crossed lines are silvered surface. The other surface is reflecting surface. According to the reflecting surface, we can name the mirror. That means if the reflecting surface is concave, then the mirror is known as concave mirror. If the reflecting surface is convex, then that mirror is known as convex mirror. We should remember about these curved mirrors making for further studies. Now we shall discuss the basic terminology about the spherical mirrors. The words which are used to describe the spherical mirrors are called as the terminology of spherical mirrors. See this figure. Here the terms are noted in that. The terminology, the first terminology is pole. It is represented by a letter P. Here we took a concave mirror. In this mirror, the geometrical center or the midpoint of curved surface which is present on the spherical mirror is known as pole. See this students, P is pole. The next word is principal axis. Axis means line. A line which passes through the pole and perpendicular to the curved surface is known as principal axis. If you draw a normal through the pole is called as principal axis. The next terminology is focus or principal focus. It is represented by the letter F. When a parallel beam of light incident on the curved mirror, they get reflected and meet at a point on the principal axis. Then that point is known as principal focus. In the case of convex mirror, the parallel beam of light get diverged. But if we extend the reflected rays or reflecting rays, they will meet at a point. Then that point is known as focus. If the focus is on the principal axis, then that focus is known as principal focus. The next word is radius of curvature. It is represented by the letter R. The distance from the pole to the center of curvature is called as radius of curvature. Here the distance is measured from the pole because the distances should be measured from the pole in the case of mirrors. So we should measure the distance to the center of curvature from the pole. This distance is known as radius of curvature. The next term is focal length. It is denoted by the letter small f. The distance of focus from the pole is known as focal length. That means the distance from P to capital F. That means pole to focus is known as focal length. In the case of curved mirrors, the focus lie in between the pole and center of curvature. That means the focus is the midpoint of the radius of curvature. So the focal length is the half of the radius of curvature. Small f is equal to capital R by 2. Here small f is equal to focal length, capital R is the radius of curvature, f is equal to R by 2. These are the terminologies of the curved mirrors. In the next video, we can learn how the images are formed. That means at which point the images are formed in the case of curved mirrors and the formula for focal length in the curved mirrors. We will learn these topics in the next video. Thank you students. Stay home and stay safe.